Okay, let's continue on to problem number 25. Again, this is in the ACS book here for organic chemistry on page 41. Let's do problem number 25. Problem number 25, you see we have a series of alkene reactions here, all four of these different alkene reactions. Remember, with an alkene, we have a flat starting material. And what's going to happen is when you have a flat starting material, almost all of the time, you get a either a racemic mixture of something or an achiral product. So here, here on all of these are addition reactions. This particular one here is unique. That one there follows Markovnikov's rule. And let me show you that. Markovnikov's rule here. This is how the ACS likes to show an acid. Now remember, this could be H2SO4, but ACS likes to just show it in this form with water. So alkene reacts with that, and we get the most stable carbocation. In this case, it doesn't matter which side it goes to. Both of those are equally substituted, so they're equally as stable. But that's something to remember, though, for other applications. Mark's rule, Markovnikov's. And then here we also have water present in the reaction. So then the next step in the mechanism, water attacks. Okay, let me backtrack. This was flat here. So this attack here, this addition of hydrogen occurs actually on both sides. This attack right here occurred on a flat intermediate right there, and that occurs from both sides. So if this does form a stereocenter, then it would be a racemic mixture. Okay, there's the water that just attacked. This is not a racemic mixture, though, because here we have two of the same thing on both sides of the ring. We cannot have two of the same thing on a stereocenter. But okay, so then a base comes along and deprotonates that until we get an alcohol from this. That's just a review of alcohol reactions, but this is not even a stereocenter. To be a meso compound, that was another thing, this definition from this book. Meso can mean lots of different things. Here, meso means it has to have at least two stereocenters. And a stereocenter is a stereogenic center is what I'm referring to. Okay, it has an internal plane of symmetry. And I'll show that here in a minute. And another key thing is it has no non-superposable mirror image. I'm trying to go a little bit fast here. Non-superposable mirror image. So three main characteristics. The fourth one here, probably not as important. It is actually an achiral thing. But here, when you're trying to identify a meso compound here, it has more than one stereocenter. So R and S, maybe both of those, whatever. It has an internal plane of symmetry. And I know I kind of sketched this out roughly. It does not contain a non-superposable mirror image. Oh, and another easy way to say that is it does not have an enantiomer at all, because it is actually achiral. Okay, so that's that here. Let's go on and review problem, letter B. Here with this one here we have bromine. Bromine is a tricky one. Bromine here has carbon tetrachloride in it. That's a solvent. That's just meant to make this a little bit scarier of a reaction. All that is doing is diluting everything. It does nothing in the reaction itself. So bromine can come up in radical reactions, and watch out for those. When it is radical, usually you'll see light or heat present, or some kind of radical initiator like peroxide. Okay, but the key words for this addition of just plain old bromine is anti-addition here. And what that means here is the bromines will go in opposite directions. So you'll get that plus that right there. Another way to draw these two pairs is to draw them as if they're looking at each other in the mirror, like this. So say this is the mirror, you would draw the reflection here, like that. And those actually are two non-superposable mirror images. That is the definition of enantiomers right there. Those are legit enantiomers, and because there's a non-superposable mirror image, this cannot be a mesocompound. Here, let me show you the contrasting view. Say we had a reaction somehow that made this, and then we go and try to draw the non-superposable mirror image like this. Okay, notice that all I have to do is pick this one up off the page, the right one, pick it up, rotate it around like a steering wheel, and the bromines fit right on top of each other. This right here is a mesocompound. This does not result in the reaction here that just shown, so that cannot be the right answer choice. Let's look at C here. C is another reaction where we have, very briefly, we have Markovnikovs. If we add HCl, it will add to the most substituted side, it being a chlorine here. And again, this is like the OH. It has two of the same on both sides right here, so that is not even it doesn't even have a stereocenter right there, so it can't be a chiral compound. That is achiral, but in this case it's not a stereocenter. And then finally, this must be the right answer. That's the one we have left over. What they've done here, they have used deuterium instead of hydrogen. Deuterium can always replace hydrogen in any reaction. All it is heavy hydrogen. So you can supplement that in any reagent. And they're using, platinum in this case to carry out the reaction. This is a syn addition. That was a previous problem, number 24. Since it is a syn addition right here, what we're going to get is this. And again, that is what we just drew a minute ago, except with bromines, the D's go on one side, and when we try to draw the mirror image, it is identical. All we have to do is rotate that onto its mirror image, and it superposes. For an enantiomer, it has to be non-superposable. That means that it will not overlap with all the atoms once you superpose it or try to overlay it. And if you look at this one, there's the internal plane of symmetry right here. Let me write symmetry rather than plane. Internal plane of symmetry means this half of the molecule over here is identical to that half, including the two mirroring D's that are there. So it's as if you put a mirror right down the middle of these, and they're looking at each other in the face. Okay, so there's the mesocompound there. This is very common for the ACS to phrase a lot of stereochemistry in terms of some kind of reaction. Right here, D is the answer on that.